this project, a robot must be designed that follows the line. Black and white cans will be placed along the track. The robot must detect these cans and move them to a storage area for each color. After 4 cans are picked up, the robot will proceed to the next crossmark in the track and stop. I started building this robot in a similar way to a previous robot of mine that only followed a line. Motors are mounted above the wheels and transmit power through a gear reduction. This gives high torque and slow, precise movements. These motor units are mounted under a large upper plate with an omnidirectional wheel in the rear. A plate is mounted between the wheels to mount the line tracking sensors. After this base chassis was completed, I tested the robot's ability to track the line. With the robot tracking the line well, I began building a gearbox and arm that would pick up the can and move them to the storage area. A motor drives the arm and a potentiometer reads the position of the arm. Mounted to the front of this arm are the ultrasonic rangefinder, another color sensor, and a servo that picks up the can. I then tested the arm's ability to pick up and move the can. With this working, I moved on to designing a system to sort the cans. I kept it fairly simple and used a box with a separator fin in the middle that can move on a servo to sort the cans on each side. There are a few main processes running in my program for this robot. The primary function in the loop gathers information from the line tracking sensors and moves the robot accordingly. The second process is reading the range finding sensor and preparing to trigger the lifting and sorting action. Once a can is detected, the program will read the color sensor pointed at the can and move the sorting mechanism. Once the color is determined, the arm lifts the can and releases it at the correct position at the top of the arm's travel. My program contains a few functions that simplified the code quite a bit. There are functions that turn the robot to the left, varying amounts. I also created a version of this function that will turn to the right. Another useful function that is used multiple times stops the robot's arms from moving. The final 2 functions are used for comparing a sensor's value to indicate black or white. The function called isWhite compares the sensor's value to a constant and returns true if white or false if outside the range deemed as white. I created a similar function called isBlack that returns the true when the value is in the range determined as black and returns false outside of this range. The robot's approach to the can was probably the part that I improved the most close to the end of this project. A straight-on approach is very important to having a reliable and repeatable robot. The main issue I noticed during testing of the robot was its tendency to overcorrect when approaching the cans on the straightaways. In order to have the robot turn tight enough, the corrections were too aggressive on the straight sections. A gentler turn would cause this robot to overshoot the turns and not be able to make it around the track. I combated this by adding additional sensors. Sensors on the edge of the sensor array triggered a sharp turn, and sensors closer to the center caused a slight turn.